Hello, hi, I'm Raj. I've got an introduction slide, so I'd rather wait and go through that. Interesting talks. Mine's slight twist. I've got a demo. I'm hoping S3 stays up, right, for it. So there's a lot to bet on. So if it doesn't, the code's in Git. There's a link at the top. So what I'm going to talk about is Azure Functions and AWS Lambda. There's a lot to cram in 25 minutes. So I've done this talk before, so I've actually squeezed it in 25. I'm hoping this will come up, right?
Do it on your laptop.
What's going on? Oh, perfect. Woo! Right. So who's this guy? I am actually a software developer, like most of you, right? I'm not an expert on Lambda or functions, right? I don't think there can ever be a serverless expert. There's so much, and it changes. There's so much new all the time, right? I'm just sharing a journey, right? So I've learned a lot, and I work in teams. So it's not my learnings, right? It's all the guys I work with. I learn from them, and we jointly, learn quite a lot every day. So what I'm doing here is basically all the pain I've gone through, all the excitement I've gone through. I'm trying to share that with you, right? So. So I've got two jobs. I'm a consultant at Equal Experts, where we write kind of enterprise software, big enterprises, move them into AWS, mainly Lambda. And I'm also co-founder of Baco, which is a kind of a marketplace for wines. It's all these little merchants who stock the best wines. They know nothing about the internet. We provide a platform for them. So you can purchase wines across Europe. And we are using Azure because we're on the Microsoft BizSpark. We are using Lambda, and we use Google, right? So we kind of use all bits and pieces, right? The best bits of every piece, right? So I'll come across why we do that, right? So I'm going to talk about my journey, why serverless, right? And that might resonate with some, might not. So mine came with the introduction to Fsharp. So I was working for a company doing C++, C# with a couple of guys here, and I learned about domain-driven design. And I was like, rocking on about domain-driven design. We read the books, and really interesting, started doing bits in C# until I met a friend of mine over a couple of beers, and he told me about Fsharp. And I was like, Fsharp? That's interesting. So after a while, we kind of came to a conclusion that actually Fsharp, being a functional language, actually works really well if you kind of use write the codomain in it, because the codomain actually, who's come across domain-driven design here? Yeah, perfect. So the codomain is the bit that differentiates you from your competitors. This is the value add your company provides. This is what your customers actually pay for, right? And it's actually where your pure domain logic lives, right? All the other services that you interact with, the kind of generic subdomains, like bits like that talk to the rest of the infrastructure. Those are services that then actually you can enjoy writing code about that, for that. You can actually get libraries for that, but actually they don't differentiate you from your competitor. This is just library code that you can lift. That code is the bit that you write on top of all that. So we kind of came to the conclusion that Fsharp, being a nice functional language, keeping it pure, works really well in a core domain world, right? It's functional. And we could actually write a lot of the supporting subdomain stuff in C++, C#, keeping the Fsharp bit really pure, right? And if you read Eric Evans' book, right, this one here, he actually mentioned this in the book, like the codomain is a domain which makes your business unique, right? This is what makes you different from another company. The generic subdomain, don't write it. And in my lifetime, I've struggled with engineers because they love writing this, right? Eric Evans in his book says, put your best engineers on the codomain, right? Get your best engineers, put them on the codomain. But I guarantee you, in every company, the best engineers are writing that software, right? Because they're the only engineers who tackle with the infrastructure bits. Yeah, they look across, they see the bigger picture. And actually, no one wants to kind of write this bit of code. And you find that all the best engineers actually end up in this world. And you find what his book tells you about is like, get your engineers in here, right? So how do we actually write more code here and less code there, right? And I think this is where, like, my journey kind of started, and I thought, actually, I don't find that exciting anymore, right? It's nice writing a library, but if it doesn't provide any value for your company, Just Eat was an example, right? We do takeaways, right? Well, we did takeaways when I was working there, and they still do. But we should be writing code that makes the takeaway experience better, not writing JavaScript libraries that make a real button click or whatever. Just use a library for that, right? So back onto functional programming, right? So what is a function kind of in the functional programming world, right? It's just data comes in, data flows out, there's no side effects. And to me, Lambda and functions is functional programming at the architectural level, right? Because what's happening at the Lambda level, data comes in, gets transformed, another Lambda hooks up. So to me, Lambda is functional programming at a higher level, right? But that's my view on it, right? But it's been a journey of pain, right? To really appreciate serverless, you have to do all this, right? You got to have to cry doing CloudFormation. Yeah, you have to have built monoliths. You got to be doing images for bootstrapping. You got to be writing a lot of infrastructure code. If you're writing infrastructure code, believe me, that is a code that rots. Your domain code doesn't rot, right? Unless your business changes, right? So your domain code is less rotting than that, right? So why write that code, right? You've done a lot of this, deployment pipelines. After doing all this, right, when you come towards the serverless world, where you don't have to do a lot of this, it's a beautiful journey, right? Yeah, and basically, I'll go through some examples, okay? So let's talk about how, right? I'm going to introduce serverless framework. So that's not my demo. That's just a hello world. So in 30 seconds, if I go to that world here, I've kind of got a serverless create template. Can you guys see this, right? Yeah, I've basically created, oh no, it's off the screen. I've got a template, AWS Node.js. I've kind of deployed it here. There you go, to this region, stage. And basically, I've actually invoked it in the region, right? So it's a simple hello world app, right? If I cat the hello world, handler, I shouldn't have had too much Coke, right? So that's the code, right, in the handler, right? That's all I have, right? And if I invoke it, I get that. It's an HTTP call, right? So what do I get, right? So basically, for 10 lines of code, I get all that. I get HA across 3 availability zone. I get scales out, 100 concurrent requests. That's a soft limit, mind you. That's a learning. So that star here, I've put there, right, is my learning around everything. So, there's a soft limit. You can call up Amazon and say, by the way, I want to increase that limit. So you get 100 of those. You get logging, free. You get monitoring and alerting, right? You get DDoS protection. Amazon doesn't advertise that, but there is DDoS protection. I think someone mentioned here, and they do a really good job of that. You get authentication using IAM for free, right? So I'm the only one who can call it. Configuration through environment variables, super easy deployment and rollbacks as well, right? So I get all that from tens of lines of code, right? I didn't have to write that, right? And there's more, actually. I'll talk about that in a demo. So I kind of put together a demo I thought would be exciting for everyone to go through. Azure Functions, very similar. I'm not going to do this because actually there's a lot of setup, and I've done that, preset it up, right? I've got 25 minutes. So I'm going to basically just tell you the experience very similar. Azure's different from AWS, and I'll cover that, right? So Azure Functions, you have to choose, right? So they've got the Lambda model, the dynamic model. So you can invoke a function, it spins it up, right? And you don't have it, right? Well, it freezes it. And then you got the app service, which is classic. There you got a container that just lives there, and you can, it's more like a ECS task, right? So you got 2 models in Azure, right? And what you can't do in Lambda is run long jobs, right? But in Azure, with this model, you can actually run really long jobs, and you get paid for it. You have to pay for it, by the way. So here's the problem. I thought I'd come up with a real problem, right? So Barco, the website. You can go and buy wines. The merchants actually upload the wines for us. They upload the images, and the images are really bad, right? Some of the images, they're not really good quality, and they not always contain a bottle of wine, which is quite annoying, right? But the worst is, it never contains a bottle of wine being sold. You get a different bottle of wine and think, oh my God, how do I solve that? And actually, what you can actually have is good images can be written. You get one merchant giving us one wine, it's a fantastic image. Upload another image, overwrites that one, and it's not very good, right? So we need something, right? We need to make Google happy, right? And we need our wine lovers happy as well. So I thought what we'd do is come up with a solution. And using Amazon recognition. So what Amazon recognition does, it looks at your picture and then figures out what's in the picture and tells you with certainty how much, what it is, right? So let's give it an image, right? And it'll tell us whether it contains a bottle of wine. The pricing is crazy. It's $1 for a million images. And actually, I've got the whole of the Amazon Prime developers on my team now, right? Because I don't want to write this, right? Then I'm going to actually use Microsoft Cognitive Services, because actually Amazon recognition is good, but it doesn't do this bit. A wine bottle has images in a weird way, right? So you look at the label, the text is never horizontal. Yeah, it's got different angles, right? And actually, Cognitive Services is really good at reading text in any image and tell you what that text is in any angle, right? So I thought, let's combine the two, right? And then give it a bottle of images. Images of bottles. And then what it'll do is basically use the two services and it'll tell me what that wine bottle is, right? And it'll tell me actually whether it's a good quality images or not, right? So this is how it could work, right? You got a merchant, we got an app, so it puts into storage, right? The worker could pull it, get a wine bottle, recognition, pass to the next worker. It could pull, Cognitive Services, there could be queues in the middle, right? Another worker job takes it and then publishes and notifies to Baco and to Slack, right? So on a front, this is kind of how I would build it, right? In a way, certain people have different ideas, but think about like an async workflow, right, with workers, right? I'm going to choose Node because actually I'm going to use Azure and Lambda. Baco is in Azure, and I'm going to use Lambda for the images and S3. Recognition and Cognitive Services. So what I'm going to do, I'm going to choose Node.js for this, right? It's simple, or I could just choose C#. I chose Node.js, right? If I build it in a monolith way, this is what it could look, right? I could put all the web code on one box, autoscaling group, could put all the workers on one box, right? And autoscaling group there, and then this could what it could look like in a monolith way, right? The traditional microservices could look like this, right? So deployment of each worker, right, onto different autoscaling group, and each worker is responsible for one thing at a time, right? Brilliant, right? So yeah, let's do this, okay? Or we could go into serverless. So what I need to consider with that is actually I need HA. If this is handling lots and lots of images from all merchants, I need to basically log services on each box. Ship them somewhere. I need monitoring service installed everywhere. Agents, yeah, that's interesting. I need to think about code deploy if I'm going to deploy it. Deployment slots, right? I need security authentication. I might spin an identity server. I love identity server. It's amazing. I might spin up another box somewhere with identity server. Then I'm going to think about licenses, database choice, other infrastructure. It continues, right, in that world. Or I'm going to use serverless. So I thought let's go through a quick overview of Lambda. So this is a super high overview. You can read more about this. Lambda has two models, right? And it consists of functions and events, right? So you've got functions, right, that handle events from different sources. Asynchronous sources could be Kinesis, SNS. Synchronous is HTTP, right? And they behave differently. So you got to read about this. Asynchronous Lambdas actually behave in a different way. They retry. There's lots to it. I'm not going to go through it. I've got 25 minutes, so they are different. So we're going to use asynchronous, synchronous. But Azure Functions consist of triggers, functions, and bindings. And triggers are equivalent to events, but you got this other notion of bindings, right? And bindings are nice, right? So whereas in a Lambda, your S3, if you put something on S3, it'll call your Lambda, right? And then let's say you want to call something else, maybe put something in DynamoDB, right? You've got to basically write the code to put in DynamoDB. With an Azure function, you don't do that. If you want to call an Azure function, put it in blob, right? It'll invoke your function. You can return something, but you tell the binding to put it wherever it wants to put it, right? You can put it into table storage. You could send a request out via, push notifications. It's all in your bindings. It's not in your code. So here's a real example. I'm going to go through my example in Barco. So it's on GitHub. This is real code. That code, all it does is on an HTTP endpoint, looks at table storage, right, and gets the merchants by ID, and then returns that. And that's my code. That's all I have in my Lambda. If you look at my function JSON, the bindings, I have bindings at input. That's the HTTP binding. That's my table binding, which I'm going to read in one call. And then I'm going to output the HTTP. That's it. All that's done in the binding. Very different from the Lambda case, right? So two different worlds, right? But I'm going to merge the two, right? So don't get scared, right? This is what it's going to be, right? I've got a single page app, React. I'm going to get a signed URL from S3, right? So what I'm going to do is basically have a Lambda that all I have to do is basically say, give me a signed URI, right? That I can actually upload my images to, right? So a bit obscure, right? So that Lambda is going to return me an HTTP URL that is going to allow me to upload to S3, right? Then I've written the bonus Lambda that actually returns everything from S3. S3 is my image store. As soon as I put something in S3, this is the difference, right? I don't have to pull anything. It triggers my AWS Lambda. That's going to call recognition, right? And then I'm going to publish the results in an SNS message, right? The SNS, I have two Lambdas. One's going to tag the S3 object. So it's going to go, I know what it is. I'm going to tag the object. And the other Lambda is going to say, oh, it's a bottle, right? That's what recognition tells me. I'm going to send it to Azure, right? Where Barco is. Okay, on the next page, I have the Azure bits. And this is what I mean about serverless. You've got to understand there's some things that work in a different way in the serverless world. So if I want to upload something to Blob, I kind of use the same patterns. So I get a signed URI. This is in Azure now. And I upload to Blob storage. It's the same pattern, different technology, right? Or a different world. And then that will trigger a call to Microsoft Cognitive Services, and then it's going to send a Slack message to me, right? So what I have here is Slack, okay? I've got images, kind of a Slack notification channel, and what I'm going to do is run the app. This is what it looks like. I've got all the code at that location in one repo. That's what the merchant web looks like. These are the Azure functions, right? All deployed from one location. Let's run the app. Whoops. So I've got fantastic UI skills here, right? So that's my React app. So what I'm going to do is upload a couple of images. So what I'll do in that folder, I've got a couple of wine images. I'm going to upload that. And I'm going to upload next one. I'm going to upload wine with background. And I'm going to upload a banana as well, actually, just out of interest. Okay. So what's happened here is the discovered tags here come from recognition. So what recognition's turned around and said, actually, that image there is a bottle, I know. It's a beverage, it's a drink. That one's the same thing. Now I have a banana. It's a banana. It actually understands it's a banana, right? And to some extent, this one here, it knows it's actually a red wine as well, which is quite amazing. And that's the image I actually had up there, which was kind of the image with the red wine. And it's kind of recognized that. So I know it's a bottle of red wine. So what I've done in my Lambda, I've pushed it to Azure. But if you go to Slack, and I'm hoping this fails, right? There's nothing in there, right? Why is there nothing in there? Because actually, if I kind of look at the logs for that label scanner in Lambda, right, you'll see that it's timing out, right? So it's trying to wake up the Lambda in Azure, right? Azure is sleeping at the moment because it's a dynamic. And what's going to happen is basically I'm going to leave it as it. What Lambda is going to do is going to retry for me. I have no code in there that retries anything, right? So I didn't have to write any retry logic, right? So what's going to happen in a bit, that Lambda is going to retry. It's quite a while, actually. I'm going to keep on talking, right? And you should see something pop up in a bit, right? While I'm talking, hopefully you see some Slack notifications, okay? So recognition's done its job. I'm hoping that cognitive services will do its job as well, right? That's the demo. So what do I get for free? I get HA, auto-scaling, security. The list is long. I'm not going to read it all, right? But everything comes for free if I enable it, right? I don't have to write this code, and that's funny after yesterday's thing, right? But S3 is amazing, right? But I get deploying pipeline, I get monitoring, alerting, right? I can also extend my kind of I think someone mentioned identity, right? I can introduce identity quite easily, actually. It's not very difficult. It's more work introducing identity in a non-serverless world. Trust me, I've done that loads of times. Just it is an example, right? So it's all pay as you go, right? So this is something I mentioned in the last place. The real cost savings for Lambda do not come from when they're running. It's when they're not being executed. So if you've got an app that's not running 24/7, right? Your savings come from when it's occasionally running. So Lambda's you're only going to get charged when things run, right? So if you're running an app that's 24/7, don't actually Lambdafy it, right? Just leave it 24/7. Lambda gives you this benefit, right? There are other benefits, by the way, of running it, but that's my take on it. This is the biggest benefit. The cost, the Monolith, 184, that design up there. Traditional microservices, 284. Lambda, serverless, $14. And by the way, I've kind of, that's what it is in percentage terms of the two previous solutions. And actually, that cost is based on T1 micros. I don't think T1 micros are going to work, but I've kind of based the cost on them, right? So the cost difference is amazing, okay? And this doesn't include the other whole overheads I mentioned, right? So testing. I'm going to skim through this. Treat them as MVC controllers. You can test in memory, right? And it's recommended. Test as much as you can in memory. The example I showed you, Hello World, I invoke the Lambda. I can invoke the Lambda locally, right? It just spins up in a node container and basically works very similar to how it works in a container, right? Not exactly, but you can do a lot of testing, right, that way. Ideally, what you're testing is your domain logic, right, not your infrastructure service. Smoke tests you do rely on these more because actually you do relying on deploying. And because it's so cheap, you can actually afford to have AWS accounts that you can deploy to within your pipeline. It's just cheap, right? Just deploy it and test it, right? So the pipeline looks very much like this, right? In-memory acceptance tests, and then you promote to the other environments. Azure Functions, very different, right? Basically, you don't have deployment slots, and then basically you've got to create two function apps, and then you swap between the two function apps, right? And that's how you deploy. So you can actually test everything in Azure and test it twice. We want to talk about logging. You can get logging for free, but we like all our logs in one place. You can actually pull all the logs out of CloudWatch, put them in Elk. You can also pull all the logs out of Azure Functions and put them in the one place. So if you want all your Azure Function, AWS logs, you can do that. But that just means that you need servers, right? Yeah, so it's not all serverless, right? Same here, right? Monitoring. This is a solution for monitoring. We use Telegraph to pull data out of CloudWatch, InfluxDB, and then Grafana and Capacitor to send out alerts, right? And this is kind of the Lambda world. The Azure Function world, you got App Insights, right? Which does the same thing for you. It's serverless. I would use that, right? But this is our solution for Lambda. It works really well. Yeah, you need servers, right? So serverless patterns, you got to think differently. Focus on domain. Be lean. Delay some decisions. Like in my decision up there, I didn't actually store my data in a database. I just tagged the S3 object, right? why need a database for anything, right? S3 is amazing, it's simple. Just delay every decision, right? Do I need a web server? Put everything on S3, right? You know, why do I need a web server, right? S3 is amazing, except for yesterday, right? Leverage cloud services, right? Use as much cloud as you can. You know, the cost of, it's not the cost of the running everything, it's the cost of the work you've got to do to actually deploy and maintain all that. It's code maintenance as well, right? It's not just, you know, like the ops maintenance. There's a lot of code to maintain. As a developer, aim to write very little code, right? And write code that matters, which is the domain code. Rely on event sources, right? And streams to invoke your code, right? And use scheduled events. Think kind of creatively in a Lambda world, and use messaging between functions. Don't kind of link them all together, right? So this is my last slide. I thought I'd put quick tips which might help, like, you know, treat your handler. Don't put your logic in there. Functions should do only one thing. Keep your dependencies to a low. You know, there's cold startup times. If you have lots of dependencies, it's going to take longer for your container to spin up, right? And your code together. Just keep it to a minimum, right? Do your one little thing in your function. I'll give you an example of a function there. There's only 5 lines of code. Keep it at that, right? Write defensive code. And actually, you know, in some cases, just throw an exception, because Lambda's going to retry anyway, right? So in some cases, it's just safer to throw an exception and wait. We hope the retry works, right? Rely on environment variables to provide configuration, and use a functional style, right? If you're using ES6, keep your code in a kind of a nice, readable, domain-centric way. That's the only thing. It kind of reads nice. The best part of it all is that you do not have to talk to any infrastructure services, right? There's no code in there that does any infrastructure stuff, which is nice, right? Questions? Oh, well, by the way, my demo, did it work? Yeah. So I have the wine bottles, right? So this guy, so recognition tells me, by the way, that's Spanish. It knows the language as well, right? And it's actually, the orientation is up, and it kind of read Rioja Urbina 2006. It's kind of read that one as well. Kind of language, I don't know what that is actually.
It's Chinese.
Is it?
Yeah.
Really? Oh, amazing. Yeah, so kind of got that wrong in a way, though. Right, and then you got this one. This seems fine, Grand Reserva. So it works, right? And there's less than 100 lines of code in that whole repo, right? So there's a lot there that you can do with Lambda, right? Thank you.
What is the banana?
The banana never made it, because what I've done is, if you look at the picture I had there, right? I have the Lambda there. Basically, it says, is it a bottle, right? If it's a bottle, then post it, right? So the banana never got posted. So this part of the world is quite clean, right? So that worked as well. Thank you.